Mr. John Pither from the aspiring medicine of Milton Keynes, London, is about to present the Clojure Flavoured DevOps.
Thank you.
Please welcome John Pither.
Thank you. Okay. Awesome conference and awesome talks so far. Okay, yeah, let's go. So I want to talk about Clojure Flavoured DevOps. I'm John Pither. I work for a consultancy that uses Clojure called Juxt, aspiring to be as good as medicine one day is our dream. So let's get started. So what do I mean by DevOps? There's lots of different terms out there. For me, I think of DevOps as transportation. If we have a jar file on our local machine, being able to transfer that to a remote server through some SSH tunnels, some build pipelines, or if we've got a log on some remote server somewhere and we need some DevOps Ninja Warrior skills to extract those meaningful bits from the logs and bring them over to the screen in front of us. This is all DevOps. It's about information traveling and moving things. So with that in mind, I want to set the backdrop. I think of this as like the base case of transportation, the sort of land wanderer, the kind of Linux warrior. And I've got a huge amount of respect for this approach of DevOps. I think it's awesome, like the people that can just walk around the earth with just a lasso, you know, a sort of a gun, and just use awk and sed and things. I mean, you know, hats off. I mean, I once tried to learn some awk and sed. I got quite good, and it sort of went into my head that I could do some good things with logs and things. But then I went on a Haskell course a week later, and that just took out all of that information from my head. And it went. But that's kind of like a point in that, you know, I want to use the same patterns and the same approach that I use for the majority of my work in this space. It's a bit like, you know, we've got JavaScript on the UI, but we want to do ClojureScript there because instead of the UI being a different system and there's two systems, we want a single system. We get some productivity gains, etc. So just want to talk about a different form of transportation as well. And these are the sort of DSLs. This is like the other extreme end of the spectrum, I think. And this is where you get things like Puppet, Chef, and Ansible. And I've spent some time in this world too, and I think these big DSLs, they just become quite hard to work with. Like they're big sort of JSON declarative documents, but then there's some Ruby magic in there. There's always like some little bit of funky sort of syntax that you get led astray with, and what is this? It's not pure JSON, it's some sort of magic that we have to get to grips with. And then it goes all OO as well. Like you start building these modules, you think that people one day sort of use them and admire the sort of things that you've built, and then no one does. So it's a bit of a wasted effort. So what do I want? Well, as I mentioned, I want to do my DevOps using the same language, particularly Clojure. Clojure is good at manipulating data, traversing data, and we do quite a lot of that in the DevOps world, so using Clojure is a plus. I want a fast startup time as well, which is key. I mean, people say that the JVM is quite quick to load up. Clojure itself can be quite quick to load up, but then if you then put your programs in there and your libraries in there, then the whole thing can be not the fastest experience. So I need to go faster than that. I want to get back to that Linux warrior. I want his sort of accessibility to speed, the ability to fire up a bash script, a script and have it go. And then I want a ready-made ecosystem. You know, the JVM has an ecosystem, and if we leave that behind, then I want something to replace it. And this is where Node comes in, something like Node with all the ecosystem and tools that it's got. So let's talk about a different mode of transportation. And this is introducing Mach, which we've built in Juxt, and this is what I'm going to talk about. So what is Mach? So Mach is a remake of Make in ClojureScript. And the philosophy of Mach is really to embrace these ad hoc scripting DevOps tasks. They're not like dirty, we don't need to be ashamed of them. It's like we can sort of bring them up, you know, we can really make them shine and make them look nice. Mach is not really about sort of building big programs with namespaces and lots of functions and lots of documentation and beautiful public-facing functions that other people will use. It's about the scripting. And Mach is, I want to say this straight from the start, it's alpha status. It's been going for, I wouldn't be surprised if it was a year now. It started by Malcolm Sparks, and then I took it over to a degree. And it's still changing. It won't change massively, but I wouldn't be surprised if there's still some small changes to occur. So I want to sort of dig into Mach, but I want to first of all state that Mach is really standing on the shoulders of giants. So Mach is built on top of Lumo, which is just awesome. I'm sure Antonio is here somewhere. Big fan. And of course, ClojureScript as well. So really, like, Mach is sitting on top of this massive giant of this tech that's gone before it. And I think it's quite amazing, really, that we're still building tools on top of these tools. But they are great tools, so why not? So I want to introduce Mach. So this is a Mach file. So Mach is a command line utility that you install with npm. You do an npm install. And then you can just type Mach at the command line. And Mach just looks for an Eden file called machfile.eden. And you can see the base case is that it's actually pretty simple. You've just got tasks on the left-hand side. This is a map. The keys are symbols, the names of the tasks. And on the right-hand side, you've got, in this case, the raw executable form, which is what gets executed when you run this task. So Mach hello, and you get hello world back. Just a bit of a cunning variant of this is that you can also pretty easily shell out. So we've got a literal here where it shells out the echo and the hello world. And you can start to get a teeny glimpse here of what is like possible in this new world, where we can shell out, we can get some data, and then we can do stuff with it. And this is some code that I wrote that I'm not particularly proud of. So don't think this is super awesome and this is the way that you should do things. But this is an example of the sort of things that you can do when you put these two things together. So at the top there, if you ignore that go take, I'll explain that later. I'm using the Mach.core sh as opposed to the literal because I want a bit more control. But I'm doing a PS, and I'm saying, look, Mr. PS, give me all of the process names and the CPU usages that are currently running. And so there's lots of chromes. They'll be at like 1%, 2%, 10%, etc. You've seen that PS before. And that comes back as a string from PS. So I then split it, doing Clojure stuff. And then I start to merge them because I want to put all those chromes together. And then I do a sort by, reverse, take the top 5 heavy programs with all their processes and just display that. And that's what we've got at the bottom there. So at the time I was listening to Spotify, sort of chilling out, listening to some music, had some chromes open, and Lumo was actually executing this. So you can see why it was pretty heavy on my CPU. But this, I'm not trying to sort of show off this amazing code. Like, you shouldn't go and use this code for your time outside of this. This is just an example of what is possible. We can do Clojure things. We can get information from the operating system, and we can use our beautiful language of choice, the language that we enjoy using that's good with data, to explore that data. Okay, but as I said, Mach is not just this glorified little bit of Clojure executor. It sort of is, but there's a bit more. It also has the concept of tasks. So this is the longhand exposition of a task. And this is what Make does. Make is built around tasks, and the philosophy of Make is more about building large programs where there's lots of interrelated, connected tasks. So here I'm defining my task, and it's the update that really does the thing that's important here, which in this case is making a directory, and that directory name is defined by product, which is target. But we can also give Mach more information about this task. In this case, it's novelty. So the novelty informs Mach when this task should be run. And in this case, it's saying when this file does not exist, when there's no directory here, you need to create it. So now Mach can be a bit more intelligent. If it's got some tasks to execute, it can call upon this novelty to determine if it actually needs to execute those tasks. And we've also got verbs in there as well. So this is a verb. If you look at Mach target clean, we're saying I want to do something with this task, but not the normal sort of update version of it. I want to call clean on it. And then Mach will dutifully invoke that clean, which is doing the removal of that directory. You can see these examples here. So we can take that and we can expand upon it. So this is an experimental bit of Mach that we worked on to compile Java programs. So at the bottom there, we've got this task called classes, and it will basically call Java-C on a directory full of source code and spit out some Java classes afterwards. And you can see here's where we're bringing in the task dependencies, which is a cornerstone of Make. So classes depends on the classes directory being created, and the classes directory depends on the target directory being created. So when you come up to the command line and you just do Mach classes, Mach will do a graph sort, and it will work out the order of how the tasks should be executed. And then if you were to do a Mach clean, it understands about clean, it knows about clean, so it would do it the reverse order and sort of pull it apart. So I want to just talk about something that we do at Juxt a fair bit. So we build kind of apps for our clients, and often we deploy them into the cloud. And we have to be compliant in the cloud, and our clients demand PDFs. They want some documentation as to why is our application compliant, what ports does it use, some information about the app, and some operations manuals as well, so we can hand over the PDF to the ops team, who then know how it's configured and how it runs, etc. So we, rather than just writing Word docs, we have built some tech for it, and we use Mach for that. So we have all our documentation in Juxt in ASCII doc, because we're quite big fans of ASCII doc, and then this XML task will then build that ASCII doc into a XML doc book. And that XML doc book, using the PDF target, we then call DB LaTeX to create a beautiful PDF with some styling there. And you can see that the PDF is dependent on the XML. The XML only runs if there's some ASCII doc in that directory that has changed. It's worth running. And same with the PDF. The PDF runs if the XML has changed, but also if someone's been fiddling with the style sheets to make the PDF look a bit more beautiful. But I mentioned as well that we like to put in some information about the application into our PDFs. So at Juxt, we use a config library called Aero, which basically it can read an Aero Eden file where we store our config. And we've got this philosophy, really, of putting all of our configuration into a single config file. So often on projects, you see something a bit different, where there's some config the application uses, but then the config that is used for deployment is somewhere else. And often there's overlap, because deployment wants to know about the ports that the application uses, so it can open some firewall rules and define the security groups, etc. So that's a bit of an anti-pattern in some ways. So we just put all the config into a single config file. And because we're using ClojureScript to do our deployments and our DevOps, it's quite easy then to read that config and use it for the deployment purposes. So we're doing that here. So Mach has a couple of directives to make life easier. The Mach dependencies at the top is a directive, and that's saying, I want to use a Maven lib here, like go and fetch me Aero from the Maven repository and make sure it's installed. It actually uses boot underneath the covers at the moment to do that. So then we've got Aero, we can start to use Aero. The props one is basically binding this var config so all subsequent tasks can use it, like this info one. And the other thing that's going on here that might not be obvious is that Mach auto requires namespaces for you. So it basically says, oh, you want to use Clojure pprint. I'll basically do a require for you so you don't have to. And this is some of the philosophy of Mach, which is to make your scripting lives easier. We do things like if you want to use a Maven lib, then we'll go and get it for you. If you want to do some prop bindings, if you want to do some auto requires, etc. If you imagine with this slide, with the previous slide, what we actually do at Juxt is that we read our config in, and then we take some of that information and we expose it to the PDF building task. So then we can do things like insert snippets of config if you want to into the PDFs that we ship to our clients, or we can just take specific bits from the config, like the port numbers and the host names of where the application is running, so the ops team can use it. Okay, just want to quickly go through some other features. So we're in the NPM world. So here, there's another directive, which is Mach NPM, and this will just make sure that this NPM library is installed. And this is left pad. Does anyone know what this is actually doing? Anyone shout out? No, it's adding 2 blank spaces to that word foo, padding it for us. Okay. We're also async in Mach. So when we started using Mach, we quickly came towards a bit of a problem in that NPM libraries like to be asynchronous. You often do a HTTP request and you have to give it a callback, which plays havoc if you've got your tasks that need each other to be finished and they need to track when those async things have happened. So recently we made every Mach task an implicit Go block. So this fetch here is executing inside of a Go block. And you can see that we declare a core async channel, and then the callback just writes something into this channel, and then we basically wait on that. And then because this is a go loop, Mac will basically wait for this to finish before proceeding on to the next task. There's a bit of funky declarations we have to do to get the core async stuff in this init directive. And we might look at making that nicer in the future, but we haven't concentrated too hard on sugaring it up at this point. Okay. Lastly, on the features of Mac, extensions. You might have seen there's some boilerplatey sort of, there can be some repetition if you've got lots of ClojureScripts, or if you've got lots of programs and they've all got Mac files, and there's similarly defined tasks, that's going to suck to a degree. You might be tempted to copy and paste, not saying that you necessarily would. But you can import extensions. So really, this is saying, this is a Mac directive to say, there's a Mac Eden file at this location on GitHub. It defines some tasks. I just want these tasks in my own Mac file. So please just go and import them. And then we can call Mac IPs from the command line. IPs is a defined task at that GitHub location. And we took some inspiration from Clojure here, so you can namespace those as well and do renames so you don't have conflicts and things. And you can pass in some configuration there, like AWS profile. OK, so I've got 5 minutes left. I think it's time to go into the clouds. So we like Terraform at Juxt. We're quite big fans of it. You know, it's a bit of an anti-pattern in the days gone by where you would go into AWS and pointy-click and create lots of constructs that you'd have to maintain. That's a security risk, and it's a headache to deal with all those things that get deprecated that you've created. So Terraform's great because you give it a declaration, and it will take that declaration and make that realized in the cloud. It will make it so. So we like Terraform. But the downside of Terraform is that it's a bit confused as to what it wants to be. Like it is this tool that can make the reality in the cloud as you want it. But at the same time, it's getting into that puppety, chef, funky DSL land thing that isn't so great. There's some OO in there. It wants you to build up these modules, and you have to do inputs and outputs, and there's some sugary DSL stuff going on, some magic. So we don't really like that so much. Terraform does allow you to not use its funky DSL so much. It does take a big JSON document as well. So what we recommend doing is, and here's a tip, use a programming language to build up this JSON that you give to Terraform. Don't just think you're constrained at Terraform and the road ends there. You can do stuff before to generate that Terraform JSON and then hand it over to Terraform for execution. So, you know, one way of doing it is to do it in Mac, right? So you've got that config file before that you could slurp in with arrow. You get information from your config. And then you can just do Clojure stuff. You can build this up. You can do algorithms, you know, map and stuff to build up this Terraform JSON. It's going to make your lives easier. And this is what we do. At the bottom there, you can see there's a call. Just to basically, when you've finished with this Clojure data structure up here and you've constructed it, just spit it out into the Terraform JSON, please. And then after this is run, you can go to the command line and do Terraform plan, Terraform apply, and you're good to go. So we didn't really stop there. We also created this thing called role. And this is having fun with this idea of building up these Terraform constructs from ClojureScript. And role, the idea of role is to build your own platform as a service. So if you look at things like AWS Beanstalk and Heroku, you know, they're big platforms. They've got load balancers, auto-scaling groups, lots of servers, some security setup, some DNS setup. And we've been down the Beanstalk route, and you know, we spent some time there, but we wanted more of our own control. We want to deploy our own stuff along with the Beanstalk-like stuff and be in full control of it. So we started building role, and role, the idea of role is with a small amount of config, the important stuff, it will then just build you all of this Terraform for you. So you don't have to start with a blank slate and think, what do I need for your average environment that runs a web app and has some security and DNS? Like, we all keep rebuilding this. And the idea of role for ourselves is a strategic place where for the next client we get, we can just spin this thing up, it will generate us a Terraform, and off we go. We've got an environment that we can use. So we define some base stuff like the sort of load balancers we want, the Route 53 aliases, and because it works with AWS for now, and the services that we have. And of course, we plug that into Mac. So here we get our config from Arrow. We've got a TF JSON, which is the Terraform JSON task. This determines if it needs to be run. Is anything changed in the role config or the Mach file? And then it's got these 3 steps here that it runs where you see produce. So it takes this config, it enriches it, because role has this thing where you don't have to define everything. It will go and enrich some stuff for you. And then it builds you this Terraform-like, it's not the actual JSON, it's a data structure before the JSON. And at this point, you can go wild with your own stuff. You can add in some datomic transactors, you can, whatever stuff you need in the cloud, you can put into Terraform at this point. You've just got that big Terraform data structure, so it's yours to do with what you want. And then finally, at the end, when you finish, this is the Terraform I want, you can spit it out into the Terraform JSON, which just does a few tweaks that Terraform needs, like gets rid of the hyphens and uses underscores and things in certain places. And that's about it. So references. So all of this stuff, we're using Edge, which is very much the hello world of Jux. It uses Malcolm's libs like Yada and Biddy. And it also uses Mach and Roll to deploy this web app into the cloud if you give it some base config. So it's a good place to go if you just want to see how this whole thing fits together. And then there's Mach and Roll. And conclusion. Embrace the scripting. It's like, let's just not think that scripting has to be some sort of crummy bash scripts on the side of our app. Let's promote them. Let's let them access our config. Let's treat them with the respect that they deserve. And let's use a language that works well with data, because often we have to do lots of data stuff in the DevOps area, particularly as we saw with Terraform. And if we do all this, then we can go interesting places. Thank you.
All right, thanks very much, John. Any questions?
There's one.
There's one, yeah. I'll give you the other mic because we have 2. There you go.
Yes, thanks. Excellent presentation. I was wondering, what if I sometimes need more power than, or if I don't understand the Eden format well, or it doesn't fit my needs well, is it possible to, say, drop back to the using pure ClojureScript to do all the Mach stuff by calling some Mach functions from that instead of using the Eden format for tasks?
I haven't tried it, but I don't see why not, because the first thing that Mach does is read the Eden file, and then that's a data structure. And then it pre-processes it, and then it executes it. So there's no reason you can't just call in to those functions and do the execution. If it doesn't work, then let us know, and we'll help. Okay, that's a question.
Yeah, so Mach sounded quite nice. So I wonder if you could just elaborate a little bit more on the power of Mach. I mean, there's a lot of make replacements out there right now, and more coming. So I'm curious where Mach stands in the whole sort of design space of these kinds of tools.
Yeah, it's an interesting question. I mean, I haven't looked at every tool that's out there, so I couldn't comment on where it fits in that spectrum. But Make is a good starting place. I mean, Make has lots of esoteric stuff in there that we've decided not to use. So in many ways, it's kind of simpler because of the power of Clojure and the fact we're using ClojureScript. You can do away with a lot of the funkiness of Make.
So maybe I can ask a more sort of concrete question. So some of the more recent tools can do, like, they build, say, they generate a file as product of one target, and then the contents of that file can be new targets. This is something that's really hard to do in standard vanilla Make. You have to invoke Make recursively. Is that something that Mach supports?
So basically, the targets become the actual files that have been executed themselves. They become targets that can be executed?
Yeah.
Yeah. It doesn't do it now, but we can look into it. And yeah, why not?
So excellent thought, aligns well with my ideas too. Do you have a vault concept for storing secrets? Like Terraform has a vault, Ansible has a vault. Is there a Mach vault?
Is there? Sorry, I didn't get there.
For storing secrets, like passwords.
Oh, for storing secrets?
Yeah.
Yeah, we tend to store our secrets in the config file itself inside of Arrow. And then we encrypt those secrets with only, and then the only way they can be decrypted is using a corresponding key on the actual server where we deploy the secrets to. And we've had lots of joy with this, actually, because normally you can do quite funky things like get the secrets from the environment variables, but we just put them into the config. As long as you set up the keys correctly, then you can store them in plain text.
Thank you.
Cool.
All right, that's it. Thanks a lot, John.
Thank you. Cheers.
Thanks for coming.